أهلا وسهلا بكم أيتها الأخوات والأخوة في هذه الأمسية الثقافية الجديدة للمنتدى الثقافي العربي في المملكة المتحدة. نرحب نيابة عنكم بالأستاذ الدكتور سمير عكاشة من جامعة بريستول، وهو الذي سيتحدث إلينا اليوم عن موضوع مهم يخص فلسفة العلوم، وهل يمكن أن يكون العلم موضوعياً. Welcome everybody on behalf of the Arabic Cultural Forum in United Kingdom. I welcome Professor Dr. Samir Okasha from Bristol University to this evening. And as we always do, we introduce our speaker to the audience by reading part of the CV or curriculum vitae for the speaker. Now, Samir Okasha, he's a professor of philosophy of science in University of Bristol. And this position was held since 2006. He was before that reader in philosophy in the same university for 1 year. Visiting positions for Samir Okasha, Research School of Social Sciences in Australian National University in 2004-2005. He had his PhD in philosophy in University of Oxford, and that was in 1998. His areas of specialization is in philosophy of science and epistemology and metaphysics and philosophy of biology and evolutionary theory and decision and game theory and philosophy of social sciences. Prizes and distinctions. Samir Okasha is a fellow of the British Academy, elected in July 2018. That's in addition to other prizes and distinctions. His research grants awarded, on the top is European Research Council Advanced Investigator Award, and that was in 2021 and to continue until 2026. Professional service of Samir Okasha, professional service of Prof. Samir, Royal Society Grants Committee, Apex Awards Panel in 2022 and to carry on to 2025. Editorial roles, he's Associate Editor of Philosophy of Science from 2014 to 2017, and Editorial Board of Philosophy of Science from 2021 ongoing until 2025. He attended many conferences and he organized himself a few of these conferences. One of them is Philosophy of Biology in the UK, University of Bristol, and that was in June 2016. Professional affiliations, Samir affiliated with the British Society for the Philosophy of Science. That's in addition to other societies and associations. As for publications, he is authored of several books. Samir Okasha has authored few books. One of them is Agents and Goals in Evolution from Oxford University Press. Philosophy of Biology, a very short introduction from Oxford University Press, and that was published in 2019. Philosophy of Science, a very short introduction, Oxford University Press, published first publication in 2002 and second in 2015. Today, Professor Samir Okasha is going to talk to us about, can science be objective? Thank you, Samir. You are welcome to the forum. Thank you.
Thank you very much indeed.
The microphone is yours.
Thank you very much indeed, Amer. It's a great pleasure to be here and to be addressing you this evening. Firstly, my apologies that I will be speaking in English rather than in Arabic. I should say that although I am by nationality half Egyptian and half British, unfortunately, I'm not a fluent Arabic speaker. So we'll need to give this presentation through the medium of English. I'll now share my screen with you.
Yeah.
So,
I can see that.
My field is the philosophy of science, and what I'm going to do is to present to you some ideas that are well known in the philosophy of science and have some claim to be central ideas in the discipline. The title of my lecture is, Can Science Be Objective? Let me just see if I can make this full screen.
Yes, please.
Do that.
Is this at the bottom of the slides?
Yeah, that's right.
Yeah. Yes, this one. Yeah.
Is that better?
Yes, it's clearer. Thank you.
Oh, okay. Can science be objective? So the themes of my talk are firstly, what I call the ideal of scientific objectivity, an ideal that I think is widely held, particularly by people in the scientific community, but also by others. The second is something I call the ideal of value-free science, of freedom from any particular values. I'll explain what these mean in a moment. And then I want to consider challenges to these ideals that have emerged from the philosophy of science, the discipline of philosophy of science, over the last 50 years or so. And I want to discuss the question of what implications we should draw from those challenges to these two ideals. So I think there's a very widespread image of science as an objective and a rational pursuit. And indeed, even the adjective scientific has come to have positive connotations. So when we describe something as scientific in ordinary day-to-day contexts, that's typically to praise it, to say that it's based on evidence, that there's some reason to believe it. If we describe something as unscientific, by contrast, that is to criticize it. This captures the widespread image of science as an objective and rational process. We tend to think of science as capable of uncovering fundamental truths about the world. And we think of science as based on evidence, not just on mere opinion. Moreover, we think of science as not tied essentially to any particular perspective, any particular individual's perspective or any particular social context or anything like that. I mean, obviously, everyone realizes that scientific activity is a product of certain social and institutional arrangements, but a very widely held view is that the content of science, what the scientific discoveries are, can be divorced from the social and institutional settings in which they arise and can be spread around the world, disseminated to everybody, and are in principle accessible to all of humanity. And finally, we like to think that science, or some people like to think that science is free from social and political values, that it's a disinterested pursuit of the truth, if you like. I think this image of science that I've been describing is something that many practicing scientists endorse. And I think particularly, probably in some countries more than others, this is a view that many educated people sort of unthinkingly accept. Now, the discipline of philosophy of science mostly has what I would characterize as a pro-science orientation. So many of us come into philosophy of science having initially had a scientific training, but then became more interested in philosophical and epistemological questions rather than in the day-to-day scientific questions. And as a consequence, most of us who work professionally in the philosophy of science have a largely pro-scientific attitude. However, philosophy of science has also posed some interesting challenges to the ideal of scientific objectivity that I've just been talking about, thanks to a number of distinct lines of argument. Some of these come from what I would call the epistemology of science, which asks sort of how scientific methods work, how certain we can rationally be of the results of scientific inquiry. Other lines of argument come from looking at the history of science, looking at how scientific ideas have changed over time, and using that to question this ideal that we've arrived at, or that science will arrive at, the final truth about the world. And still distinct arguments that challenge the ideal of objectivity come from the sociology of science, from people who study how scientific ideas get disseminated within a community, for example. I'll start by briefly describing a doctrine that's sometimes called scientific realism in contemporary philosophy of science. The label is relatively new, but the idea is old. And the idea is simply that science aims to uncover the true structure of the world, and moreover, that it often achieves this aim. Not always. Everyone recognizes that science can go wrong. We can think of many examples of science and the scientific community thinking that they knew something that later we found out that they didn't. But nonetheless, scientific realism says that very often science achieves this aim. Now, that may sound like a fairly innocuous doctrine. I mean, who would disagree with that, you might say? Other aspects of scientific realism include the idea that science is cumulative. So over time, scientific knowledge becomes bigger and bigger as it builds upon the discoveries of previous generations, and that it's progressive. So we can make a contrast between change and progressive change. I mean, lots of things change, but some sorts of change are progressive in that we go from worse to better, if you like, less knowledge to more knowledge. Those are all aspects of this doctrine of scientific realism. Now, traditionally, scientific realism has been opposed by a doctrine called instrumentalism or anti-realism in philosophy of science. And anti-realism is the idea that science isn't really trying to discover the ultimate truth about the world at all, and that something which may not even be possible, but rather has a more pragmatic goal of making models of the world that work, that enable us to correctly predict things and to build instruments and to make interventions that we want to make. So this is a pragmatist alternative to scientific realism. That's one very classic debate in the philosophy of science, the opposition between scientific realism and this instrumentalist alternative. However, today, I want to set that debate aside in order to focus on two perhaps more radical critiques of scientific realism. The first of these comes from an author called Thomas Kuhn, who was an American historian and philosopher of science in the mid-20th century, based at the University of Chicago, and who in 1962 published a highly influential and famous work called The Structure of Scientific Revolutions, in which he attacked the orthodox scientific realism of the day and insisted that it was a flawed way to look at science and was not true to the history of science. And Kuhn offered a radical alternative, which I'll briefly describe, which involves challenging this notion of scientific objectivity. So his first claim was that scientific realism, in particular the idea of science as a cumulative and progressive enterprise leading to the final truth about the world, was a deeply flawed picture, false picture of the way science has actually developed. He claimed that it's just something you sort of put in the textbooks in order for pedagogic reasons. But that when you look at the messy development of science historically, then you see that it's nothing really like that. So scientific realism is untrue to the history of science, Kuhn maintained, in that the history of science is not simply a linear progression to the truth. Central to Kuhn's positive claim about how we should understand science was what he called a paradigm, or a paradigm, as some people pronounce it. Now, paradigm for Kuhn involves a theory and an associated set of disciplinary practices and assumptions. And Kuhn maintained that in the advanced sciences, he was mostly thinking of the physical sciences, and his own background was in astronomy, in fact, that scientific discoveries were all based around what he called a paradigm, which is a shared theory and set of assumptions that everybody takes for granted. Kuhn contrasted what he called a period of normal science, when the existing paradigm is not questioned, with what he called scientific revolutions or revolutionary periods of science, when in a period of radical upheaval over about 30 years, an existing scientific paradigm would get overthrown and a new one instead put in its place. So Kuhn's examples of these scientific revolutions included the Copernican revolution, which led to the overthrow of the geocentric model of the universe, in which the Earth was believed to be at the center, and replaced with the heliocentric model of the universe, in which the sun is at the center of the universe, and the Earth is just another planet revolving around the sun. That was one example of a revolution. Another example involved the Newtonian revolution in mechanics, in which the old Aristotelian ideas about motion were overthrown by Isaac Newton, leading to the Newtonian revolution in the 17th, 18th, and 19th centuries. Then in the 20th century, Kuhn described a number of revolutionary episodes, such as the discovery of the theory of relativity by Einstein, and later quantum mechanics, which led to the Newtonian picture being overthrown. These are all examples of revolution. But Kuhn insisted that most of the time, when a revolution isn't happening, the day-to-day activity of science involves assuming that the paradigm is true, not testing it, not suggesting, it's not really up for question. This was Kuhn's central claim. But over time, Kuhn maintained, a paradigm would accumulate what he called anomalies, empirical phenomena that couldn't easily be fitted with the existing paradigm. And in a scientific revolution, a paradigm would be overthrown. Now, Kuhn then made the radical claim, the radical epistemological claim, that a newer paradigm isn't necessarily better or closer to the truth, but really that it's just different. It could be better in some respects, but worse in others. Because he maintained that there was no objective, theory-neutral way of comparing two radically different paradigms. So he actually wanted to say that the geocentric model of the universe put forward by Ptolemy, that dominated science, astronomy for centuries, and the rival Copernican model in a sense, could not be objectively compared, because he claimed that it's not possible to stand outside of a scientific paradigm and to compare how well the paradigm does with reality itself. That's a flawed picture, Kuhn maintained. So he claims then that there's no fully objective basis for these paradigm changes, and that to some extent, he claimed that the persuasive power of scientists plays an important role, and a new paradigm will become established in a scientific revolution, he claimed, only when there's a generational shift and the older generation of scientists die and are replaced by a new generation. So this then paved the way for a sociological analysis of scientific change that was highly controversial, and something that many traditional philosophers of science in the 1960s and 70s reacted with horror when Kuhn put forward these ideas, claiming that what he was doing was undermining the scientific enterprise. In the Kuhn talked about a conversion experience which leads scientists to believe in a new paradigm instead of an old one, deliberately evoking the language of religious experience in order to describe how the scientific community would shift allegiance from one paradigm to another. Highly radical claims. And so then, in short, Kuhn maintained that science is not cumulative. He claimed that later scientific theories and paradigms are better in some respects than their predecessors, but not in any straightforward linear approximation to the truth. Okay, so how do these ideas look sort of 60 years or 50 years from when they first appeared? Well, I think there's certainly some truth to Kuhn's descriptive claims, although whether they generalize to all of science is perhaps more debatable. I mean, his description of how scientific ideas change, of how the history of science becomes greatly oversimplified in scientific textbooks, and how new revolutionary scientific ideas are established only with a generational shift. Certainly there's some truth to those claims. Although I think it's true also to say that the claims are less applicable to the life sciences, about which Kuhn knew very little, than they are to the physical sciences, which was his home. And I think that the claims do pose a real challenge to our conception of science as objective and rational, but yet do not undermine it completely. And the idea that social and non-rational factors could play a role in science is important, but I think it's also important not to overstate it and not to think that this is inevitable or something that can't be overcome if we think it's undesirable. So what I want to do is briefly describe two sort of Kuhn-inspired challenges that I think are still potent. And the first concerns the idea of the scientific method. So we teach our science students very often about the scientific method. And many science students will take courses in their first year in what's called the scientific method, that's often comprises a sort of mixture of statistics, of experimental techniques, and of hypothesis testing and more. But one interesting question you can ask is whether there is such a thing as a trans-historical scientific method that applies to all scientific eras and all scientific disciplines. Can we really genuinely identify something as the scientific method, say, which Galileo would have used and which the modern scientists today use? Can we characterize it precisely? Then the second challenge I want to raise is the question of whether science is self-correcting. I mean, we all recognize that scientific error is impossible, but it's very natural to hope that social and institutional arrangements and the social organization of science means that eventually the truth will out and the errors will be eliminated. So although science is inevitably partial and fallible, but nonetheless it'll exhibit a sort of self-correcting character. But the challenges that are simply involve asking, are those things true? What then of the scientific method? I mean, the phrase clearly has some meaning. I mean, we can certainly point to the experimental methods of particular sciences. Say, if you study molecular biology, for example, then you study very precise and specific methods, for example, for sequencing DNA or doing whatever. We can point to more general aspects that apply to not one science, but many, such as the method of experimental control, for example, methods for testing hypotheses, the use of randomized controlled trials in medicine, for example, clearly constitute part of the experimental method. And then we can point more generally still to statistical methods, such as significance testing, for example, that again can be applied extremely widely and are. So clearly there is some content to the idea of the scientific method. It will be an exaggeration to say that it means nothing. But nonetheless, I also think it's true to say that these methods fall far short of an algorithm for finding out the truth about the world. I mean, it's not as if we can outsource scientific discovery to computers. I mean, obviously, in the era of big data, we rely very heavily, some sciences more than others, on data crunching, and that has enabled scientific discoveries to be made. But an element of judgment, of scientific judgment, is still always required. And a belief in an algorithm of that sort that would just sort of take data and spit out hypotheses that could then be discovered to be true was part of what Kuhn was attacking. He maintained that when you look at the history of science, you see no evidence that there is any such algorithm. And one way you can make that question more precise is to ask the following questions. I mean, suppose you've got two individuals who are both rational and they receive exactly the same information. They're fed exactly the same streams of data from the world. Let's say, hypothetically, all their lives, they receive exactly the same streams of information. Should they end up believing exactly the same thing about the world or not? One traditional ideal of rationality says, well, yes, they should. But if one of them believes X and the other believes Y, then that must be because of differences in the information they've received, or else one of them is irrational. But Kuhn insisted that that's not true. He maintained that you could have rational divergence of opinion despite shared information, simply because there's no algorithm for forming your beliefs on the basis of information about the world. And I think that point is probably right, although there's much more that can be said about it. So I would want to steer personally a middle course between what Kuhn was saying about there being no algorithm for scientific discovery and the idea that the scientific method has no content at all. That's clearly an exaggeration. I mean, there clearly is such a thing as the scientific method, even if it falls short of an algorithm for forming beliefs about the world in this sense. Second issue then, about whether science is self-correcting. I mean, uncertainty and error are a key part of science, and in large part, that's why we have statistics. But we often hope or assume that in the end, the truth will surface, the truth will in the end, come out. That's to say that the inevitable noise in the scientific process will wash out and will not hamper our ability to get to the truth. And this is sometimes expressed by saying that science is a sort of self-correcting mechanism, in that erroneous scientific ideas will be discarded and correct or better scientific ideas will be preserved, in a sort of analog of the Darwinian mechanism, in which the good stuff filters to the top, the bad stuff is eliminated. And you might think that certain institutions, such as the institution of peer review in scientific journals, and scientific norms, such as honesty, making one's data public, citing accurately, etc., should help to ensure that this is the case. But one can certainly ask whether that's really true. Many people may have heard of what's been called recently the replication crisis in a number of fields, which began in the field of social psychology and then spread to other fields, in which researchers tried to replicate existing ideas and found that even very well-established ideas could be replicated experimental findings could be replicated far less frequently than one would hope, perhaps as rarely as 40% of the time. It's one figure that's been put out there. That 60% of the time, an established experimental finding could not, in fact, be replicated. A variety of hypotheses designed to explain why this is, but it's certainly worrying if true. I mean, part of the problem may be publication bias, selection bias, as well as possibly dishonesty in a few cases. More generally, I think we can ask whether the social and institutional organization of science is optimal given the aim. I mean, for example, is the incentive structure of science, the fact that young scientific researchers are under enormous pressure to publish ideas, is that optimal given the aim of science? Those are questions that one can ask in this area. Okay, so that's the first half of my lecture. Now I want to talk about something very, very different, a different aspect of scientific objectivity. And this concerns the question of whether science is, or should be, or could be value-free, different aspect of objectivity. What I mean now is the idea that science should be free from social and political values, so concerned only with the objective facts about the world. The previous half of my talk was about how certain we could be, if you like, that we can really discover those objective facts. But now I'm talking about leaving that aside, talking about something else, about whether it's right to think of science as just concerned with the objective facts about the world, whether or not we can really discover them, free from political and social biases. I think it's a very widely held view, the view that science is concerned only with matters of fact, not with questions of social and political value. And indeed, it has its philosophical underpinning in the work of David Hume, who was a famous 17th century Scottish philosopher from Edinburgh. Among many other great achievements, one thing that Hume did was to insist on a distinction between facts and values. And this is enshrined in Hume's famous dictum that an is doesn't imply an ought. So he said that there's no logical way you can proceed from statements which describe how the world is to statements which describe how the world should be, to evaluative statements, if you like. So this is a dichotomy then between factual statements that describe what the world's like and value statements that describe how the world should be, according to someone. And I think it's a very powerful idea to say that there's a fundamental logical gap here. That however many factual statements you've discovered about what the world's like, that can never tell you what's right or wrong, or something like that, or what's good or bad, or what ideals are worth pursuing or not. And now in the 20th century, this idea of Hume's became enshrined in what was known as the naturalistic fallacy, which involves doing what Hume said you shouldn't do, namely trying to move from statements about how the world is to statements about how the world should be. That's what 20th century philosophers came to call the naturalistic fallacy. Now, this is a very general philosophical idea, but it has an application to science. And the application can be seen in the well-known idea that the job of the scientist is just to discover the facts. And what society does with those facts is another matter entirely. This is, for example, something that's widely held in the field of genetic engineering. Where scientists say, look, we can discover if it's possible to, genetically alter some embryo in some way or other. But the question of whether society wants to do that is a question for other people, not for the scientists themselves. And you saw this distinction also in the COVID pandemic. where the scientists would come out and say, well, look, you know, our job is to tell you what will happen if you do X. So here's what will happen if you do nothing. You've got no lockdown. Here's what will happen if you do lockdown in terms of viral spread. But the question of which of those is the right thing to do and how long the lockdown, if any, should be, if you have one at all, we can't tell you that, because those are matters of value. Now, I want to ask whether this idea is a noble ideal or is it naive? I think both of those views are out there. Some people say, look, this is essential. Science, you know, science is disinterested, it's a search for the truth. That's the Hume position. But another opposing view says, look, that's extremely naive to think that you can make this separation. And I want to discuss two challenges to the idea that we can make such a separation. And the challenges take the form of trying to argue that facts and values, although different, are sometimes so closely intertwined that the idea of separating them becomes impossible, or unachievable, and perhaps even naive. And the first point I want to stress is that sometimes value judgments can be implicit or deeply embedded in what looks to be objective scientific research. So it's all very well if the value judgments can be just clearly separated, as in the COVID case. You know, here's what will happen, here's what the models show will happen if you do X, different from the question, should we do X? But in some cases, the value judgments can't be separated out that way, because the very categories or concepts that scientists use to describe the world objectively, as they say, may themselves reflect value judgments. So one example of this concerns a notion that some people may have heard of, a very unfortunate notion that was prominent in 19th century science in the English-speaking world at least, and quite possibly elsewhere, where people believed in something that they call feeble-mindedness. So behavioral scientists and eugenicists and geneticists, human geneticists, believed that there was this condition that they call feeble-mindedness that was a heritable condition, supposedly. Today, we would say that many of the people who they described as feeble-minded, you know, had learning difficulties of one sort or another, or possibly mental health conditions, or traumatized, or something. But in any case, they believe very firmly in this category, and they believed that it was a heritable, genetically determined thing, and that the feeble-minded should be prevented from reproducing, should be prevented from breeding. And my point here is that it would not be a good defense if a Victorian scientist said, look, I'm only interested in the question of the heritability of feeble-mindedness. That's my research. The question of whether you want to try and stop the feeble-minded from breeding, reproducing, that's a question of value for society. I'm only interested in the objective facts, discovering the incidence of feeble-mindedness and its heritability. I would say, no, that's not a good defense of them, because there is no such thing in the first place. I mean, they were operating with a category that itself embodied problematic value judgments, and that we now know to be based on pseudoscience, not genuine science at all. And so in this case, you see that you can't possibly say, look, let them get on with the objective science of studying feeble-mindedness, and let the politicians and the other people decide what to do with that objective information. Because the value judgment is intimately bound up with the scientific category itself. More controversially, something similar can be argued with relation to the very category of mental illness. So a famous book by the Hungarian neuroscientist Thomas Kuhn from 1960 called The Myth of Mental Illness, argued that the very category of mental illness itself was a sort of pseudo-scientific category embodying all sorts of value judgments about what patterns of behavior society did regard as permissible and what not. So it was not an objective category at all. So that's my first example of how value judgments can be implicit rather than explicit, and so threaten this neat dichotomy between describing the world objectively and deciding what to do with that information on the basis of your moral or political values. The second example is different but related and concerns this point. I mean, which objective facts should we study in the first place? I mean, clearly there are very many different things that you can study in science. I mean, the range of possible objects of study is almost unlimited. So scientists need to decide which objective facts they're going to study in the first place. And here I draw attention to a notorious book from the 1990s about intelligence, about IQ scores, by the authors Herrnstein and Murray, called The Bell Curve, in which they were interested in the observation that there is a black-white differential in achieved IQ scores in the US. On average, the white population scores slightly higher than the black population in IQ scores. That's an established empirical fact. Now, there are very many hypotheses about why that is. I mean, social and educational impoverishment being one of the most plausible ones. Herrnstein and Murray tried to argue against that, insisting that there was, in fact, a genetic basis to IQ, a highly controversial view that many people think is not true. And I think it's fair to say that they did not succeed in persuading the broader community of psychologists and behavioral geneticists of this viewpoint. And on the basis of that, of this claim that the differential is genetic rather than social in origin, they went on to argue that the US state should remove funding for, or withdraw funding from certain social initiatives as it encouraged low IQ individuals to reproduce. A very, very unfortunate line of argument, reminiscent of arguments made in the 1920s and 30s that we thought we would not see again, but we did. Now, the point I want to make, though, is not whether what they said is true or isn't, whether their hypothesis that this differential is attributable to genetic rather than environmental, social, and educational inequalities is true. I'm leaving that aside. But I want to ask this question. I mean, why care about that in the first place? Why think that's an interesting thing to study? I mean, you can find correlations between all sorts of different things in any population. If you divide up the human population, according to some criterion or other, you can almost certainly find some attribute that will differ between the two populations you've divided up. But you have to ask yourself, well, is that an interesting finding or not? Does it show you anything interesting? Why study that thing? And another example of the same thing, I think, is the obsession that some people in the field of evolutionary psychology have with supposedly innate male-female differences in various proclivities, various psychological aspects. Again, I'm not saying they're wrong to think that there are such differences. Maybe there are, maybe there aren't. But you have to ask the question, why do they care about that? I mean, of all the interesting things you could discover about how the human mind works, many of which will be common to males and females, the majority of which will be, why focus on this? Why focus on this particular research topic, which has dominated this discipline? And so that's my second point, that even if Hume's dictum that you can't get an ought from an is true, the idea that science seeks the objective facts, free from contamination by social or political values, is, I think, too simplistic. At best, it's a regulative ideal. But fact-value intertwining can take quite subtle forms, as I've tried to explain. Okay, so to conclude then, I started with this image of science as objective and rational, and pointed out that the adjective scientific is has positive connotations usually. There's obviously something right about that. I mean, clearly we should applaud modern science for many of its great achievements. But also that ideal, that image faces challenges. I've talked about the ones coming from Kuhn, about how certain, how sure, how much faith we can place in scientific discoveries and the idea that science is getting to the truth. And the one coming from Hume, and that issue about whether we can really separate out facts and values, challenge to objectivity in a different sense. But my final take-home message is that I think what we need to do is to steer a sort of middle course between a harmful science skepticism that doesn't accord science the status that it deserves, and an uncritical science worship that fails to take account of some of the points I've been making about the history of science, about the epistemology of science, about uncertainty, and about the intertwining of facts and values that should make us question to some extent this image, though not rejected entirely. Thank you very much.
Thank you. Thank you so much, Prof. Samir. And before I can open the discussion regarding the lecture, very interesting subject and very thought-provoking, as well as we can read your books, and there are examples in your books, in the two books that I'm going to mention the contents of it, just to attract attention of the audience. Philosophy of Science, a very short introduction that was published in 2002, second edition 2016. What is science? Scientific influence, explanation in science, realism and anti-realism, scientific change and scientific revolutions, philosophical problems in physics, biology, and psychology, and science and its critics. So that's the one book, the very short introduction. Of course, I should say that very short introduction is a good series from Oxford University Press, and there are about 80 books of very short introduction about different types of subjects in life. The other book for Prof. Samir Okasha is Philosophy of Biology, a very short introduction, and that is the content of it, which was published in 2019. Why Philosophy of Biology? Evolution and natural selection, function and adaptation, levels of selection, species and classification, genes, and the 7th chapter is human behavior, mind, and culture. And that's really very interesting. Maybe, Prof. Samir, we can speak about this subject next year with you, because I'm so eager to have you again in this forum and this very important subject.
That would be great. My pleasure.
Yeah, that would be great. Now, with me is Faisal Qadri. Yeah, the microphone is yours, Faisal. Thank you.
Hold on. Thank you. Thank you, Professor, for this very interesting talk. My first inquiry is, why is objectivity important? Why is it even relevant? Because I have a modest contribution in this, and that is sort of the importance is of the measurement of the process of measurement. I have an article that says that asks, are all observation measurements? And in order to have a valid measurement, then what you need is two aspects. One of them is the reliability of the measurement. The other one is the resolution of the measurement. And if you look at even the most objective, quote and unquote, sciences, you will see that the reliability of physical measurement goes all the way back to time. And it becomes a measurement of time. And even time, you can say that there is an element of faith, let's say, of non-objectiveness, because time, we cannot be sure, or we are even probably are sure that time did not exist before 14 billion years. So it's the objectivity is a continuum. And in order to have a valid measurement, we don't need to establish objectivity. That's what just a comment. If you're interested in my article, let me know.
Yeah, no, that sounds very, very interesting. I mean, so when you say that we don't need objectivity, what do you mean by that? I mean, you mean different individuals can produce different measurements and that doesn't matter or something?
No, wait a minute. Well, that is the essence of the argument that you brought about the objective science and instrumentalism. Instrumentalism is basically what you're saying, and of course, I'm also have a background in cybernetics, second order cybernetics, etc. I don't know if you know that much about that anyway, but of course, truth and reality is relative according to this, and that's how Einstein proposed his theories, and it's widely accepted. What I mean is that there is a way of agreeing over a model, let's say a model of behavior, and you can measure with respect to a model of behavior any perturbations, or you can establish, if you have a valid model, you can establish accuracy and resolution.
Right.
So
Okay.
once you establish accuracy and resolution, that's it. That is a measurement.
Yeah, no, I mean, I've got no problem with the objectivity of measurement. I mean, obviously, you've got your measurement error, but I agree with you that that's no threat to objectivity in this sense. No, that certainly seems to me right. I mean, the sort of objectivity I was talking about in the first half of my lecture could perhaps be expressed like this. I mean, suppose we have some scientific hypothesis, for example, about some environmental exposure that causes a certain disease. And then we have a whole lot of evidence for it. Then, I mean, generally we like to think that there's a matter of fact about certainly whether the hypothesis is true or not, and also about whether the hypothesis is or is not supported by the evidence. That those are not things that there can be rational disagreement about. Right.
Yeah.
And that's the sort of thing I was meaning, the objectivity, if you like, of evidential assessments.
Okay.
Now, that's, I think, slightly different from the objectivity of measurements. I mean, I entirely agree with you that it will be an odd and radical view to say that one couldn't attain objectivity of measurement in the sense of agreement among different individuals, different experimenters, all attempting to make the same physical measurement. I mean, that would seem odd. But what I call the objectivity of evidential assessment, I think, is perhaps more debatable.
Yeah, I think there must be some kind of distinction between physical reality and social reality, because social reality is way more relative than physical reality. But then again, what I'm saying is that the difference between the two is really quantitative, not qualitative, because in the end, even physical realities must relate to some kind of a measurement that has some element of faith or element of unknown. Okay, that's it.
Thank you.
I don't want to take anybody else's space.
Thank you, Faisal. Thank you. That's great. Now, now we have another two guests would like to engage and questions and have questions. We have Dr. Salam Sam. تفضل Dr. Salam. أهلا وسهلا.
Thank you very much, Samir. Fantastic lecture. And thank you, Amer, for inviting Samir for this very important presentation. And I enjoyed it thoroughly. What I want to raise is a worry about, first of all, the scientific discoveries and the science and so on have to be factual, and people who make these facts and record them, they have to be honorable and truthful about this. Otherwise, we will have a problem. My worry at this time of age is the worry about the dissemination of disinformation not based on science and how that has affected the real figures and measures of science. What we have seen over the last couple of years is the huge interference of media and how media has distorted the picture. In the past, مثلا أنا لما أروح أحضر lecture, I go to the library where there are books and there are scientific journals that I use, and these are controlled within the boundaries of this library, which is a recognized place for science. Nowadays, you can get somebody who looks like Einstein talking about an idea which is opposing his ideas of relativity and so on through a video created by artificial intelligence. And how this explosion of uncontrolled data has actually invaded our space and made those people who are not aware of the scientific discovery or the truth to deviate from understanding the reality of it.
Yeah.
Thank you very much, Salam. It's a very important point and also a very worrying phenomenon that you discussed. I think your last observation. I mean, I suppose it's tempting to think that although all of that ChatGPT and AI stuff will and is already being used to undermine, to spread misinformation and false information, and to undermine so many things, that natural sciences and social sciences should be immune to that. But I very much doubt that that really will be true. I mean, I think certainly the gatekeeping in scientific journals is essential and works really quite well, I think, though obviously not perfectly. But I think the problem really will arise with the dissemination of scientific information to the public. I mean, that's where the big challenge is already a very difficult business, that. And that's where the big challenge from, I think, large language models, ChatGPT and things like that will really be posed. I mean, I suppose a more optimistic take is to say, well, the explosion of big data has been wonderful for some sciences. So if you think, for example, of the protein folding problem in molecular biology, that they always thought was, almost impossible to solve. I mean, how do you determine the three-dimensional shape of a protein?
That's right, and also to make a vaccine against. Yeah,
right.
Within less than a year.
Exactly.
Example of that is important.
That's right, absolutely incredible, and facilitated in part by data, by the enormous expansion of the quantity of data and the computational tools for dealing with it.
Yeah. Thank you so much. Thank you.
Right. Thank you, Salam. And of course, you raise very important issues, the freedom from personal biases and objectivity of science. Isn't it, Samir? That's really very important as part of the objectivity, is the freedom from personal biases. And that's really important.
No, I entirely agree. Yeah. I mean, that's it for me. A key part of the meaning of objectivity is that you're not tied to any subjective perspective, any individual subjective perspective.
Yeah, yeah. Okay, now, Dr. Yahya Yunus, تفضل Yahya.
Thank you, Dr. Amer. I want to thank also Dr. Samir for his nice information he gave us now. I'm not specialist in the philosophy, but as I will speak as economist and the relationship between philosophy and economics. Actually, the relation between any philosophy of economics may be different. As a social science, you know that ways of methods of research and understanding the economic phenomena historically came under three stages. We can distinguish three stages. The first one, it was the relationship between philosophy and economics is very clear, because usually the first thinkers, economic thinkers like Smith, Marx, and others, and before that as well, depended on the old philosophy of Plato and others. So it was like, a bridge between ethical content and philosophy in dealing with the economic thoughts. That's the relation continued until the what's called in economics marginal school, which replaced physics in a state of philosophy to understand and explain the economic phenomena. So it is very easy to see all the journals now, and before even, full of the mathematical equation explaining that this movement actually make economics like, it was excessive use of mathematics, and some economics or thinkers describe economics then that like physics of social sciences. Then after that, I mean, recently, some critics come from the people who say that's excessive use of mathematics and models that will not, far from reality, return to not just philosophy, but philosophy and other social sciences like psychology and politics as well, public relation, you can say that. This subject of this actually explain more realistic phenomena in the economy, any economy. And we saw recently the rise of other branches of economics like environmental economics, behavioral economics, feminism, different evolutionary information economics. So in this case, some concepts in your lecture about we have them, like normative economics and positive economics, how the world should be. But unfortunately, until now, that's not actually related to science, but related to politics more than economics. Yep. So just I want to see some explanation. Can we use philosophy as a way of dealing with all sciences, I mean social and life sciences, in same way or in the same extent? Thank you.
Thank you very much.
Yes. Yes, thank you very much. They're very interesting observations. I mean, my actual first degree was in half in economics, half in philosophy. So I was interested to hear your thoughts on that. I mean, there is such a thing as the philosophy of social science. Yeah. And in fact, that's a flourishing discipline. And one of the interesting questions in that area is precisely, is there a methodological continuity between natural science and social science, or a fundamental discontinuity? And I think you're absolutely right that certain fields in social science, particularly economics, have very much wanted to model themselves on the natural sciences. But whether that's been successful, I think, is open to question. I mean, because for all the enormous mathematical sophistication of contemporary economics, then I mean, the question whether they put all that mathematics to use is a different one. I mean, because physics, then you make mathematical models, but also they have a really high degree of predictive accuracy, indeed an astonishing degree. And in economics, then that bit is the bit that's missing. So, I mean, I think there's a real question about whether copying the methods of the natural sciences has been useful or not in the social sciences, and whether it's one of the classic questions, in fact, is whether the methods of social sciences must be fundamentally different because they're dealing with social reality and human intelligent subjects or not. I mean, it's still very much an ongoing debate.
Yes. Yeah, thank you for that. Thank you very much. We have Prof. Najib Al-Haboubi. تفضل. Ustad Najib, if you are hearing me.
Mute. Yeah, my name is Najib Haboubi. I'm a simple biopathologist with interest in science. And it's a privilege actually to be part listening to you, Professor Samir. How far is your thesis away from Karl Popper's? We have learned that for the falsification, for following the falsification theory, is that our, shall we say, work or projects or theses are open for falsification and we keep distilling this falsification program until we purify it. How far are your philosophy is from Karl Popper?
It's a good question. Influenced by Popper, but I think Popper simplified some matters. And in particular, his idea that falsification is the whole story about science, I think not many of us accept these days. And also Popper tried to insist that inductive reasoning is illegitimate in science. So that's reasoning from a sample to a population, or from limited finite data to a general truth. Popper insisted that you can only disprove your theories. You can't prove that they're true. However, many of us feel in the philosophy of science, including myself, that that can't really possibly be right. I mean, certainly we can never prove that a empirical scientific theory is true in the sense in which we can prove that Pythagoras' theorem is true, for example. That's right. But clearly, there is such a thing as inductive evidence. So many of us think that although Popper said a lot of sensible and correct things and was the most influential philosopher of science of the 20th century, at least in the English-speaking world, that nonetheless, ultimately his methodology is too simplistic and leaves out one of the most crucial things, which is how probability and inductive reasoning work. And that until we have a better understanding of that, we'll never really understand the scientific method. So that's my major disagreement with Popper. But there are also lots of points of agreement, like with the fallible nature of scientific inquiry, the fact that the self-correcting nature of it, and the rationality of science, I think, are all themes from Popper. And those are all things that I also agree with.
Yeah, well, I'm glad actually you mentioned the self-correcting, because actually that is something which is very useful. But that actually comes with education, and it's a process. It doesn't actually come automatically.
No, I agree.
Yeah. Well, thank you very much indeed.
Thank you, Prof. Najib. Thank you very much, and Prof. Samir. And of course, this subject is all about how objective is the science and why objectivity is important for science, and the trust with the people. And Samir, you mentioned about COVID-19 and the information, that the flood of information that we had, and misinformation as well. And it's all about people trusting the science and the scientists and their work, isn't it? Thank you, Samir. Do you have any last words to say, Samir? And thank you.
Just to say thank you very much for attending my lecture and for all your interesting feedback. It's been a very great pleasure, and I will be happy to discuss with you again. Or if anyone wants to send me an email, then please feel free. You'll find my email. If you Google my name at the University of Bristol, it's readily available. I'll be interested to hear from anybody.
Very good. Thank you so much, Samir Okasha, for being with us today, the 8th of September, 2023. Now, we will meet again next week, I hope with different subject maybe, less heavy than today's subject, and it might well be about cinema and Iraqi and Arabic cinema, the past, present, and the future. And we will be meeting one of the Iraqis cinema director, going to be with us. So thank you, Prof. Samir, and welcome to all next week as well. Appreciate that. This meeting, this lecture has been recorded and is going to be uploaded in the next few days on our YouTube channel of the Arabic Cultural Forum in United Kingdom. Thank you very much. Bye-bye.
Bye.
Bye. Thanks.